Hi, everyone. Welcome to our February Technology and Practice webinar. We are kicking off 2020 with tips on Citrix app layering from Dan Lazar and Rob Dylowski. Please keep in mind that we will have some time at the end for Q&A, so feel free to submit your questions at any point throughout the presentation. And also note that the recording will be available at the bottom of the registration page in about a week or so. So without further ado, take it away, Rob.
Thanks, Michelle. Hi, everyone. So what we're going to talk about today are some of the key features that were added in 2019 to app layering. If you look at this slide, you'll see our dev team was pretty busy during the year, and they added a lot of features, some tactical, but a lot strategic. What we're going to go over today are the user layer repair, search index persistence in the user layer, the new compositing engines for both Hyper-V and vSphere, a feature that's part of the new 1912 LTSR called User Personalization Layer for CVAD, a new early access preview for an app layering cloud API, which is really exciting, right? And then Dan's going to go over some of the upcoming features that are going to be developed in 2020 as well. So let's get to it. The first thing is user layer repair. And you might say, well, what is that? What does it mean? And it's a pretty simple concept. It's the idea that we can remove files and registry settings from the user layer that are in a defined app layer that an admin created as an app layer. Right? And if you ask yourself, why would I need to do that? The first thing to realize there is that the user layer is always the highest priority, which means it takes precedence for any setting or file that it has in it. So if users, for instance, delete an application when they have the user layer attached, that application will always remain deleted even if the admin decides they want to deploy that same application later as part of an app layer. So this process will help with that. If users install an application that later the administrator wants to deploy centrally and they'd like everybody to use their standard version, that of course is going to take precedence in the user layer as well, right? So this will fix that where it'll kind of remove it and clean it up from the user layer, so you're using the admin's version and not the version installed by the user. One thing I didn't put on here that sometimes is important, sometimes you just need to clean up some junk that got in the user layer, right? When you deploy a new application, it's causing issues. You can actually create an app layer and put files and registry settings that you want to clean up in it and really use it just to clean up user layers as well, right? Which is probably the last use case here that we put as part of that. How does the process work? When you create an app layer, up on the share that we store the app layers on, we'll create two files. There's a JSON file that's like a flag file used to tell the ULayer service when a user logs in, I want to run this process, right, for this layer. And then there's an associated package app rule file, which lists in it the registry settings and the files that would need to be cleaned up as part of that. So, the way it works kind of is the JSON file acts as a flag file. It has within it the ID of the layer, right, the name of the layer, and then the revision that you're going to clean up as part of that. And then the package app rules file gets associated with that as well. So when you go to actually run the app layer repair, what you need to do is copy that JSON file, the flag file, repair file, into the same folder as your user layer, so where the user layer VHD is. And then as the user's logging on, the ULayer service will look there, it'll see those files and say, oh, I need to clean these up. And right before the user logs in, it'll do that cleanup, so the cleanup's done when they log in. So that's a manual process. You copy it there. In order to make that process easier kind of at scale, I actually, over the holidays, created a small utility. It's called the user layer repair utility. And what it'll help with is you can load it and pick an OS layer. It'll load all your application layers and the repair files for those. And then it'll also find all the user layers for that OS layer and allow you to copy whichever repair files you want to whichever user layers you want without going to figure that out manually, right? So you could say, hey, I have this layer that I want to clean up for everybody, select all the users, and then copy it out, and it'll automate that process for you to make it more efficient. The last thing to talk about with user layers is troubleshooting, right? We write into the normal ULayer service log, things that happen when you're doing the cleanup of the user layer. So if you look in program data Unidesk logs on BDAs, you'll find that those settings, and if you're trying to troubleshoot something that happened with this process, information should be in that log to help you do that. Okay. Next thing we're going to talk about is search index persistence on the user layer. Right? It's another really important aspect of what was developed this year. It's important to realize what we had before, right? So before this feature, which came out in 1910, every time you logged in, if you had an OST file and it was and you had indexing turned on, or if you had file system indexing turned on, indexes were recreated every logon, right, to the system. So the system, you'd log in and it would kick up indexing and do that for each logon because we didn't have the persistent feature as part of that, which is actually a big problem with the user layer if you were using OSTs mainly for that, or things like OneDrive or Katana, etc. So now what you get is when you log in, it'll create the index, but it will persist them from session to session at whatever state it ended at. When you deploy it, the indexes get built on the next logon and saved, right? And you do get immediate results for that. And then over time, of course, the load goes down. Whatever is in your indexing options is included in this. So if you add things in there, they will be included as well, right? It's a universal persistence for that. What are the big benefits here? And there's a few, but the main one is you were using a lot of processing before to do that indexing every time you logged in. That processing, if you had lots of users doing it, would slow down logins, would kind of hit your servers hard, right? And all that goes away now. You're going to have it the first time when users log in, but then you won't have it after that because the indexes are persisted. So you should get faster logons. You should have better utilization on your hosts, right, and not have to worry about this high CPU used to do indexing all the time. From a compatibility aspect, your Citrix profile management is not required to do this, but you can use it in conjunction with it. That's not a problem. Some people use CPM as a backup to the user layer in case the user layer gets corrupted. They still have some of the settings. You can still do that. What you can't use is the CPM version of roaming indexes, right, to a container. That would be incompatible, and the indexes would get corrupted and not work if you did that. However, the FSLogix version of that, if for some reason you wanted to keep OSTs and that profile stuff separate, you can do that with FSLogix. It'll work okay at the same time as user layer, right, if you want to mix the two together. Okay. So now we're going to switch over to compositing engines for Hyper-V and vSphere. The Hyper-V compositing engine came out in 1910, and for vSphere it was in version 1911. I find these to be one of the more exciting things that we did last year. And you might ask, what's a compositing engine? And it's a lightweight ephemeral appliance running Windows PE that's doing self-compositing of packaging workflows and publishing workflows. Right? So instead of the app layering appliance doing that work to do packaging and publishing, it's done by these Windows PE virtual machines. It's controlled via REST API. It supports VHD, VHDX, and VMDKs with integration to hypervisor. It supports UEFI, so on Hyper-V you can now do Gen 2 machines with UEFI, and on vSphere you can do UEFI as well. It does use iSCSI to attach disks from these WinPE appliances back to the app layering appliance, right? So you have to have port 3260 open between those two for it to get back to that. That's how the appliance accesses prerequisite layers, OS layers, writes back into the appliance to save the disk to the appliance. And then the last one on that list is pretty important too. We're no longer limiting how many of these packaging or publishing operations are done at the same time. If you don't know it, the other way of doing it limits to 4 because we don't want to use too many resources on the Elm because this uses a lot less resources on the Elm. We don't limit it at all. Of course, there is a practical limit. We'll talk about that in a few minutes there for that. What does it take to deploy a compositing engine? So the first thing that happens is the Elm appliance creates a configuration ISO, and that includes its own IP address so the compositing engine knows how to talk to the appliance. and authentication information to make it secure to talk between the two, right? Those are included in the ISO. The Elm then uploads the WinPE ISO image, which is, in the neighborhood of 500 meg, up to the hypervisor and that configuration ISO. It creates a VM without a hard disk based on the connector configuration settings, snapshots that VM, then attaches disks in the hypervisor of whichever format it needs to. So, if it's vSphere, it's VMDK. If it's Hyper-V, it's going to create a VHDX. And then it powers on the VM, which boots up into the compositing engine first, right? So what you'll see is the compositing engine come up, and it'll sit there, register with the M, and be ready to take REST API calls that it uses to do that. So, there are two things you do with compositing engines. There's packaging, right, and publishing. We're going to talk about the process for packaging first. And if you look at the life cycle of a compositing engine, right, we're first going to discuss it without caching because it's a bit different depending on how you have your connector configured to use caching or not caching there. So without caching, when it creates the appliance, right, the connector deploys that CE appliance. It has those disks attached that we talked about, right, and a disk that's writable. It's going to kind of combine the OS layer, any prerequisite layers into the single disk that it has and boot that up into the WinCE appliance. It then registers with the Elm that it's ready, right, to do packaging. The Elm uses the REST API for the appliance to create the composite boot disk, right, basically connecting the iSCSI and copying all the boot files onto the single disk that it creates to work with. After it's created the boot disk and it's all ready, it uses BCD edit. It reboots itself and it turns itself into the packaging machine, tells the Elm kind of that it's ready, and then you're using the packaging machine to do packaging just like you did before. So you log into the packaging machine, you install any of the applications you want to install, one or more, you create whatever files you want to create, really any of the changes you want. And then when you click the shutdown for finalize, that machine is going to basically get rebooted back into the compositing engine, right? And finalize the layer and write it to disk and be done, right? So it's pretty neat, pretty simple process. And the key thing there is without caching, you're going to have that single disk there. If we look at how this works with caching, right, there's a few changes to the process. Instead of creating a single disk that has all of the files on it that it boots from, it creates a mini boot disk, and then it just attaches all of the required prerequisite layers and OS layer in the hypervisor. So it's a bit quicker there because the mini boot disk really just has the filter driver for app layering that brings it all together to make it look like a single image. And then all it has to do is attach those disks that are already created on the hypervisor, right, and attach to them. If you have disks that aren't in the cache yet, right, so let's say you pick a prerequisite layer and a new OS layer and those haven't been cached yet, what the app layering appliance will do is spin up a compositing engine for each of those to create that disk. So that works pretty quickly. It's going to basically do a publishing function just for the one disk. It's going to tear those down, and then it's going to then use those cache disks to create the packaging machine that you asked it to create, right? So it's going to basically make sure that those disks are in the cache before it uses them. So some interesting notes on this process. As I said, the compositing engine itself gets rebooted to become the packaging machine. It's actually the same VM, so you'll only see the one VM in your hypervisor that's based on that. And it uses BCD boot to change between which one it's booting from, whether it's the compositing engine or the packaging machine. That VM is configured with those two ISO files that it used to create the compositing engine. But after the packaging machine is created, it's important to know you don't need those two disks anymore. They'll be there, but if you need to, for instance, add a D drive as a cache disk, or you want to change the machine in any way, add NVIDIA drivers, what have you, you can change that at will. You can just delete those. You never have to put them back. We took a snapshot at the beginning. We're going to go back to that, so they're just not needed anymore. So that's an important one to realize. The boot disk for non-caching packaging here is going to have basically a single disk with all the files copied into it from the OS layer and any prerequisite layers. And the compositing engine is going to do that by connecting back to the appliance via iSCSI, right? And if you look at that, what you're going to see in the, vSphere, for example, here is one big disk. And that big disk is going to have a couple partitions. It's going to have the boot partition, which will include all the OS files. Any prerequisite files will be combined into that. And then there's a second partition, which is where you write all to. And that's actually becoming the layer, right? So that second partition, anything that goes into that, that's actually what's captured in the layer. If you're using a caching connector, it's a little different in that when you look at the disk, it'll have all those disks attached, like we talked about, right, from the cache connector. So any prerequisite layers, the OS layer will be part of that. And then there's just a mini disk on the boot disk, right, that has the filter drivers we use for app layering, and then still that blank writable partition that you write into. So, if you can use it and you have the space for it, I always say caching is much better. You'll get better performance, right? And I think you'll be happier as an admin using that. If you don't have the space, you can do it without caching. Right? Okay. A couple things on the caching. If you're not using compositing engines, every time you upgrade, your cache gets reset and you have to put all the new layers back into the cache again. That's not true with compositing engines, the way it works. Those files stay in the cache after upgrades, so that's a benefit. You don't have to recreate them and go through the slow process until you get the cache files created. And just remember, it's the CEs, as I said, that create those cache files, right? So if you don't have something cached, it is going to spin up a CE, and you might be wondering why it's doing that. That's to create the cache files in the first place, right? And the last one on this list, I think, is really important. If you use vSphere, in the other version, you'd see, after we published a VMDK up, they would kind of publish it up and then sit at 100% while expanded it from a thin provision disk to a thick provision disk. You won't have that anymore. We now support thin provision disks that are of the right type immediately on vSphere, and we write to them directly. So there's some serious performance increases due to that. Plus, you get thin provision disks instead of thick provision disks by using this. Okay. The compositing engine itself has a very minimal console interface, right? It's really just showing the REST APIs that are being called. So if you look at that, that's what you would see on your packaging machines, right, or the publishing while it's happening. It should show like that with REST APIs. If it doesn't, if you see like a command prompt there or errors, then you might have to work with support to see what's going on. Usually that's some kind of misconfiguration in setting up the ports that are allowed between the appliance and the compositing engine, or disk problems or permission problems or something like that, right? But it should look like that screenshot most of the time when it's working correctly. Okay. Next thing, remember the DVD stuff, right? You can remove those if you want. You can change the hardware if you want, right? So if you have to add NVIDIA, you can do that. You don't have to put it back, as we discussed before. Is another neat part about how this works. All right, now we're going to switch to the imaging side of things from packaging, right? So here, this is, I'm going to publish to a hypervisor. So this would be publishing for like MCS on vSphere or Hyper-V, or for Horizon View, et cetera, doing a direct publish of a VM to the hypervisor. And it works pretty similarly, right? We deploy the compositing engine, right? And then the compositing engine lets the appliance know that it's ready. The appliance will create any iSCSI targets that the CE engine needs to access to create the image. So like if there's 24 layers in your image, there'll be 24 targets created that can be mounted by the appliance. Then tells the appliance to start its job. It will mount those, right? And then it will write those into the layer that it's creating, or the image layer that it's creating, which is actually sitting on the hypervisor that it's trying to do. At the end of that process, the Windows CE device will use BCD boot to define which partition it's going to boot from. It'll then roll the VM back to the snapshot, delete that snapshot, and then attach that disk that it created to the VM. And again, the VM itself that it's making is the same machine as the appliance was. So it'll then leave that out there as the image and that's done. So it's a pretty straightforward process. The thing to realize there is most of the I/O that's happening is from the appliance directly to the compositing engine, which then writes it into the hypervisor as it goes along. Some general information to be aware of. What connectors are supported here, and if you think about it, it's Hyper-V and vSphere connectors that are working with the hypervisor. So Microsoft Hyper-V, machine creation for vSphere, VMware vSphere, and the VMware Horizon View are all the connectors that you can use this with and enable it on currently. More will be added later as we go along. Realize this from an imaging standpoint is not going to work for PVS because that has a whole different process, right? There's no hypervisor involved in that. There's an agent on the PVS server that it's talking to, so this doesn't help with the performance of publishing in PVS. It does really help, though, with the performance of packaging and publishing to the hypervisor. So what you'll see here, if you look at the blue lines, that's the offload compositing times, and for the most part, they're better than double the performance of what you had before. On the vSphere side, a lot of that is due to the direct writing to the VMDK and being able to use thin provisioning and not having to wait. But Hyper-V also has similar numbers, maybe not quite as good as vSphere because the change is not as drastic, but you will see much better packaging and publishing times with the offload compositing. Some limitations on the technologies. You know, a lot of times you're doing UEFI to do secure boot. Secure boot is supported if you're just doing published images, but you can't use it with elastic layering, and that's because the driver we use in elastic layering is not signed appropriately for that. Right? Hopefully that'll get fixed at some point in the future. UEFI is not supported on Windows 7, and that's a Microsoft limitation, but they don't support it. What about scale limits? Talk a little bit, if you think about it, you know, we said there's no limit, and you can run as many of these compositing engines as you want at the same time, but of course there is a limit on what happens to your environment when you do that. You have to worry about network performance, especially on the app layering appliance, right, where you're going to be copying a lot of those files via iSCSI from. We do have a limit of 625 iSCSI targets for that. I think that you'd see a network problem before you probably use more than that, but that is configurable. So if it really becomes a problem and you're not seeing other issues, you can increase that number by working with support. Hypervisor resources are certainly something you have to worry about. Are you using too much CPU, memory, or disk space in the process, right? The appliance will try to clean itself up if something fails, right? And then you can start over again. One thing to keep in mind in our testing, 10 simultaneous jobs work just fine, right? 40, maybe the agent crashed and flooded the network, right? So means you're in between there somewhere. I'd say 10 to 20 is around probably the max number where you want to be, but you certainly can do testing and decide for yourself how that would work. You know, the good news is the appliance isn't used for anything production, right? So if you did do some testing and overdo it a little bit, it's just going to affect whether something gets published or not. It's not going to affect anything to do with the users or that kind of thing. So what about migrating to compositing engines? How does that get handled? So if you're not using UEFI, right, you just want to do this for the performance benefits and the way that it works, all you have to do is enable compositing engines in the connectors that you want to use it with. And then add a version to your OS layer using that connector so that the drivers get updated within that OS layer before you start using it to do more packaging. So that's pretty simple. If you do want to switch to UEFI and say Gen 2 and Hyper-V with an existing deployment, we ask that you do all your packaging on Gen 1 machines because that's where you've done it with all your other layers, right? And then you create a platform layer that's Gen 2/UEFI if you're using vSphere, and when you publish your images, they will be UEFI based on that, but you'll still do all your packaging as BIOS related. Right? If you're starting fresh with a new OS, or you're starting fresh with app layering from the start, so you're using a new OS, your gold image still has to be BIOS. We can't yet import a UEFI image, though that's coming. But you'd start with BIOS, import it, add a version to your OS layer, convert that to be UEFI/Gen 2, right, depending on what you're using. And then you can do all your packaging and everything with UEFI, and it'll be consistent throughout, right? So that's the plan for how to do the migration and those things, and you should be successful if you follow those policies. All right, so now Dan is going to take over and do the rest of the presentation on those things that we haven't covered yet.
Thanks, Rob. I'll jump right in here. So I'm going to start by talking a little bit about another new feature in app layering called the user personalization layer for CVAD. We're real excited about this feature. It's actually a new, fully integrated feature into virtual apps and desktops built using app layering technology. So it's actually a new CVAD feature and not an app layering feature per se. We designed this feature to replace our deprecated personal VDIS technology, which we've been, anxious to get out of the product now for a couple of years. UPL is the official replacement for PVD, and it's worth mentioning that if you currently are relying on PVD catalogs in your environment, it's definitely worth planning your 1912 LTSR upgrade and deployment of UPL. Currently, the PVD components are no longer part of the 1912 VDA. However, we will be planning to fully remove PVD from the product before the end of this year. So definitely plan your migrations as early as possible. UPL, as we call it, is really doing a very similar job to what PVD used to do, which is enabling a persistent user experience for non-persistent pooled catalogs. However, we have really enhanced the functionality a lot, and I'll talk a little bit about that. But essentially, the aim here is providing user layer functionality from our app layering products without requiring deployment of a layering appliance to enable this. And as such, we also support modern Windows 10 workspaces, just like app layering user layers, and it is a cloud deployable feature as well, which is, of course, something PVD was never able to support. So a few of the benefits of UPL over PVD. The UPL writable layers attach instantly and in real time from a Windows network share. And unlike with PVD, there's not a lengthy inventory process when creating or updating in the master image. We also can support both pooled random and pooled static machine catalogs, where PVD only ever supported static. And as I mentioned, UPL can also support modern Windows 10 VDI, which PVD only could support Windows 7. So there's a lot of additional advantages. It's worth asking the question, if you're an app layering customer, which feature are you interested in? Are we talking about UPL or the full user layer feature? And it helps to ask some questions to kind of arrive at an answer. For example, are we already deploying layered images with app layering? If so, then it probably makes sense to enable user layers within app layering to gain those benefits that are already integrated into the app layering product. If you're not already using app layering, though, then and if you're not planning to deploy in the near future, then UPL presents a great opportunity to get a user persistent experience within your pooled Windows 10 catalogs. So that's definitely something to look at. Another question to ask is, are you managing application deployments using SCCM? And if that's the case, you may find that UPL is a great feature to deploy alongside SCCM. It will most likely simplify the management of that and can actually enhance your SCCM deployments by adding persistence to what normally is required for static machine deployment. And what if you already have user layers deployed? Do you then also need to consider deploying UPL? And we say not necessarily, unless you also have non-layered pooled images that could benefit from user persistence, or you require to manage the user layer repositories via studio policy, and I'll talk a little bit about that as well. And then lastly, as an important note, at this time, it's not supported for migrating from the full user layer feature and app layering to UPL, and we are interested in supporting this capability, and we'll be looking to add this in the future, but currently at the present time, it's not supported. So real quick, I want to run through the process for setting up UPL in a CVAD environment, and I think you'll see that it's really pretty simple. the first step is prepping your master image. And during VDA installation, the catalog type you're going to select for this is either going to be MCS or PVS, because we're talking about non-persistent. Then you can include UPL as an additional component, which is a new option in the 1912 version of the VDA. Then when you're in Studio creating your catalogs, you'll either be selecting a pooled random or a pooled static catalog. And the important thing to note in this case is if you're deploying as a pooled static, you also need to opt to discard changes because UPL does expect the desktops to reset on logoff. So you want to make sure that you have that option selected. And then last step is just creating a policy on the Studio side that defines the location of the layer repository that the VDAs will be connecting to. And we've added new policies that are baked into Studio in the 1912 release that allow you to set this up, and it's really pretty easy. And that's it. Once you've done these steps, then you have UPL ready to go. So a few things to know about user personalization layer. You'll want to avoid replacing the master image with a different installation of Windows, as it can cause some issues when the user layer is attached, depending on what changes are applied in the image. So therefore, our best recommendation is making patches and updates to the same master image that you plan to use with UPL and deploy that as part of a catalog update instead of replacing that image entirely. Also, you will want to avoid installing apps in the user layer that require any early boot time access to Windows or make use of the Windows driver store. So you will want to make sure your users aren't installing these apps, as those can cause issues. The user layers attach at login time, and therefore applications that have those early boot dependencies will not function correctly. You will also want to be mindful not to create conflicting Studio policies for the layer repository path. The user layers can attach to only one desktop at a time, so if you kind of accidentally or you know, if you're not careful about this and the policies conflict, then you may have a case where users are trying to mount a layer that's already locked for write on another session, so you'll want to try to avoid this as well. You also will want to avoid applying GPOs in your master image during authoring that will potentially attempt to configure the repository paths. UPL is really designed for to stay idle and inactive until it's deployed as part of a catalog, and therefore we intend for those policies to be the only place where the repository paths are activated. If you configure this information in the master image, the UPL services will prematurely try to mount the share during authoring, which will definitely cause you some issues, so you'll want to avoid this. And then the last point here is if you're using SCCM alongside UPL, you'll want to make sure to follow Microsoft best practices for implementing SCCM in a VDI environment, a Citrix VDI environment. There's a great knowledge base article that Microsoft published that discusses this, which you can easily Google and get that. Another point here is make sure the CCM exec service is running before your users are running Software Center in their images. We've gotten some reports of issues where if users don't wait long enough after login and they attempt to start Software Center, they can see some instability there or some unexpected issues if CCM exec isn't given enough time to start. And then as far as availability goes, as I had mentioned, we shipped the UPL feature as part of the 1912 LTSR back in December. It is a compatible component of CVAD. It will be on the current release maintenance track, but it is fully supported. The full user layer feature of app layering is still a premium add-on. It was from the beginning, and that is still the case. However, I'm very happy to let everybody know that UPL is available for any current CVAD customer. As described, we were looking to replace personal DDisk initially as the main use case. So we're allowing any customer who might have had that dependency to get free access or included access to UPL. So we're real happy to let everybody know about that. So now I'm going to switch gears here, and I'm going to talk a little bit about our new cloud API. So why the big buzz around an API? Well, it turns out that there was a bit of a problem with many of our customers who were using app layering. Our large enterprises have been letting us know for quite some time now that they're very challenged or even blocked from using app layering at scale. So why is this the case? Well, if you have large numbers of applications that you're trying to manage into individual layers, the scalability of managing that through our traditional management UI becomes very challenging. It just, it ends up being a lot of clicking and potentially a lot of waiting around. And to date, we really haven't had any tools to help drive automation for these types of workflows, especially for customers dealing with multi-site or hybrid cloud. So our solution is we've been hard at work at building a new cloud-hosted API service that is fully capable of driving all of these management capabilities within app layering through an API, a RESTful API. And currently, we're in preview with this capability, and initially we have 4 API functions that are available to our customers to help with this. We have resource management, job management, layer, and layer versions. And across these 4 API functions, we are enabling new workflows that customers can automate, including creating and managing their layers automatically, queuing and monitoring long-running jobs or asynchronously running jobs. You can now manage resources that are registered to our cloud API service, such as your layering appliances. And of course, we can query the cloud service for collections of data that relate to layer properties, resources, or anything else that the API is managing. So there's really a whole new world of capabilities that are made available by our API. So while we're in preview with the API service, there are some prerequisites to be aware of in order to make use of it. Currently, you do require to have an on-premises layering appliance that's installed and configured. You will need also an additional connector appliance that facilitates or proxies communication from your Elm into our cloud service. Currently, the appliance is available for both vSphere and Citrix hypervisor. However, when we do GA the service, we will be expanding support to all additional platforms that our connector agents will be able to run on. You will also require to have an OS layer already prepared and imported into the appliance in order to use with the API. And you do require access to Citrix Cloud, which means you need a cloud customer ID. There is no extra entitlement for use of the service, but you do have to have an active Citrix Cloud ID in order for us to enable it. And then to use the Cloud API service, once you've satisfied these prerequisites, you will also have to register your layering appliance with the service, and there is a series of API calls that you can issue in order to do that. So as far as availability of the API goes, it is currently in a preview period. The preview is open for enrollment. If you're looking or interested to sign up for this, there is a blog post that I recently published that talks about the Cloud API, and there's a link to our enrollment there, or you can reach out to Rob or myself directly, and we'd be happy to get that link to you as well. Currently, our planned duration for the preview is through the first half of 2020. However, that could be extended depending on how our progress with developing the API and the type of feedback we're getting. We are also planning to introduce new API features during the preview. And once you have been enrolled for the API, you will receive a welcome email with documentation and resources to help you get started. And you will also have access to a forum that you can post to give us feedback or ask us questions. And a note there, too, is that we are doing a controlled rollout of this service, and therefore, after you enroll, it could be some time before we're able to enable access, just something to be aware of. So now I want to take a real quick look ahead and talk about what's planned for app layering for the rest of this year. So in 2020, we will be looking to do some additional work to enhance user layers in UPL. We are actively looking at releasing support for server VDI for UPL. Now, this is actually something that is already supported within the full app layering user layer feature. However, UPL currently is not able to. It's not a component that's available as part of the server-based VDI installation. So we're looking to enable that use case. We also will be enhancing the capabilities for the sizing of the user layer disks. One thing that we hear frequently from app layering customers is that it's difficult or can be difficult to increase the size of user layers when users happen to fill them up. So we'll be enhancing user layers for both app layering and UPL to allow for automatic user layer disk expansion. So this is a really kind of cool new feature that's coming. For offload compositing and compositing engine, as Rob had alluded to earlier, we are working on releasing OS import support with compositing engine. So this will enable our customers to build Gen 2 UEFI images from the start and import them as new OS layers, whereas today, as Rob had expanded on, we only support doing that with Gen 1. So we're excited to offer this capability to make that process easier. For the app layering cloud API, we will be adding template management to the API as an additional capability in addition to the 4 function calls that are currently in preview. And then lastly, as we look kind of further out into 2020 and beyond, we're looking at now enabling new types of workflows to create seamless hybrid cloud management capabilities within Citrix Cloud. These are new integrations, kind of like what we've been doing with UPL, and we aim to really dramatically reduce the complexity and the challenges for many of our customers looking at managing hybrid cloud solutions. So we're looking at seamlessly moving workloads from on-premise environments into cloud, all powered by app layering technology. So these are some exciting things coming down on the roadmap. So now I just want to review real quick some key takeaways for this session. Just as a quick recap, user layer repair, significantly enhancing management of user layers, search index persistence, putting user layers on par with CPM and FS logics, really improving performance around indexing, compositing engines, which is a really tremendous new feature within app layering aimed at radically improving operational efficiency with the product. Our cloud API, which is in private tech preview, supporting new automation workflows and allowing customers to use the product at greater scale. And then a lot of other new and great stuff coming in 2020. So really exciting times for app layering, and we're real glad to be working with our customers on this. So.
Great. Thanks so much to both Dan and Rob. And if you just can't get enough tips, make sure to check out our Citrix educational offering, and note that you'll actually get 10% off your next purchase. And then be sure to mark your calendars for June 10th. That is our next tips event. It's going to be on Citrix Cloud on Azure. So be sure to check that out and even subscribe to our series. And now it's time to dive into the live Q&A. All right, and joining Rob today to help field these questions, we have Ozan Kandamar of the engineering team. So first up, are user layers now supported on Citrix virtual apps and desktops, previously Zen app, or is it Zen desktop / VDI only?
I can grab that one, Michelle. Just like before, because of the way the user layer works, we can't do it on multi-session OS, so you can only use it on a VDI desktop. It could be a server VDI or a desktop VDI, but it has to be single session only.
All right. And does can app layering work in an environment that is packaging the applications using SCCM and APPV technologies?
I can grab that one too. So I suppose you can use it a little bit with SCCM now. We did some work to make SCCM work better with user layers or the UPL, so people are using that now. It's a little hard to deploy or create your app layers with SCCM because most organizations require SCCM packaging machines to be joined to the domain, and ours aren't. So usually you use the MSIs, like meaning the same MSIs and scripts that you use for SCCM when you create your layers. And you can use AppV with app layering, right? It integrates okay. If you want to deploy layers using AppV kind of pre-deployed or cached, the main thing there is you have to only have one layer that includes all the pre-cached stuff, otherwise the metadata kind of writes over itself. So you can use them, a little less so for packaging of app layers than for pushing it out to desktops that use the user layer or the UPL.
Perfect. All right. And then is UEFI supported for creating an OS layer in Server 2019 or Windows 10?
Hi, Michelle. I can probably grab that. So we currently actually have UEFI support through only adding revisions to OS layers. So at the time of the initial import, we're not able to support UEFI with the current released product. However, we have an enhancement that's to follow shortly in the March release that we're targeting that will eliminate that barrier, and users will be able to import an OS layer from the beginning from UEFI. So there's no limitation today to use it, to publish images, to package, as long as you start from BIOS initially and convert in a subsequent OS layer revision. And that limitation is going to be eliminated soon in our subsequent release.
All right, thank you, Ozan. Next up, when will the ELM deploy a VHDX file for a vDisk by default when publishing images on PVS?
You want to take? I mean, I guess I can take that, and you can add color to that, Ozan, if you know. I mean, I think the answer is that we don't have that right now on the roadmap. We're not changing the way PBS publishes. You can use a script I wrote to do that conversion if you want. It's since we don't write a lot to those VHDXs or VHDs, the VHDX is not as important as it would be otherwise if you were kind of creating versions and writing to it. But we know people want that, and it's something that's there. We haven't had the time to do that work yet, and Ozan might know a little more about it than that.
So we're able to publish VHDX to Hyper-V, and there's the possibility of, if this is very important to a user, there's the possibility of hand carrying those disks or converting them before using with PVS, but we don't have direct support for that at the moment.
All right. So this one makes me chuckle. I know this is probably a naughty word, but what about AWS support?
I can take that. So at the moment, actually, we are working through a few architectural changes, sweeping through the product, specifically being more cloud-friendly and be able to integrate with CVAD workflows is one sweeping architectural change. The other one is, actually it's kind of tied into it, but there's the compositing engine support, changing the architecture of how applications are packaged and how images are published. The roles of the traditional roles of the appliance and compositing operations are evolving. So among those at the moment, AWS support is not short-term in our roadmap. We get this request quite frequently, and it's fresh on our minds, but at the moment it's not actively being pursued in the backlog. It's just a matter of priorities, and we understand the interest in it, and however, in the short term, it's not in our backlog at the moment.
Now, we do have customers that do use AWS, but I won't say it's easy. They basically scripted writing an image to a share, converting that image from a VHD to an AMI, and then importing it into AWS. So I don't know that I would recommend it to most people, but it is possible to do.
All right, and is a ELM required for UPL in 1912?
I can grab that. For UPL,
Sure.
you don't need app layering at all, right? It's a standalone feature that gets deployed with the 1912 VDA. You just turn it on and create the one policy, and that will deploy it out to the share that you define in the policy. So you don't need an app layering appliance, and all you need is a share, a highly available share, right? That's high performant, plus the VDA. So.
Actually, I can add maybe just a very short color to that. The exact reason why UPL exists is so that you don't need to have an Elm. So there are different use cases with app layering or layering technology, I should say. One is through the use of full app layering product, and we're actively creating and responding to requests from the field, from our customers and potential customers, about how they want to use the technology. So UPL uses 100% standard and regular layering technology. It's very, very close to its full user layer cousin in code and binaries. It's some parts of it, very few parts of it are different. Almost it's 99% identical. And by using layering technology, we broke the barrier of you don't need to really, if that is the ideal scenario for you, which in some cases it is, in some cases it isn't, you can prefer to use on your own image. Persistence can be provided by layering technology, which is the user layer, in the form of UPL, and Rob already touched upon how you configure and where it comes from. So yeah, Elm is not involved at all.
All right, and sounds like we also just took out the question of what is the difference between user layers and UPL. So next up, I do see a lot of questions coming in about Nutanix and the future. So Ozan, I'll let you kind of speak to that a little bit.
I'll take that, Michelle. Thank you. So I kind of alluded to it in an earlier answer. I think that there are a few sweeping architectural changes in the product. Compositing engine we're very proud of, and it is slowly making its way around to different platforms. Nutanix, unfortunately, is not in our close kind of short-term roadmap at the moment. However, we would eventually like to bring the advantages of compositing engines to all platforms. That's in our goals. So even though short-term, I have to say not at the moment, it's on our long-term backlog.
All right, thank you. And is UPL available in both CVAD 7.19.12 and CVAD 7.19.12 LTSR?
I can answer that.
Take that. There is maybe, or
go ahead.
Yeah, sure.
Yeah.
Let me give the quick answer, Rob. If you have anything to add, you can go ahead. So the 19.12 LTSR is the first LTSR that UPL is offered. So earlier LTSR 7.15 does not contain that feature or functionality. And all subsequent releases after 19.12 LTSR also contain UPL. I hope that draws a line, but I don't know if I missed anything.
No, it's fine. Just a quick update there. There is no CR for 19.12. It's just the LTSR and X is both. So there's really only one version there, and it has UPL. And the next CR versions will also have UPO.
All right. Next up, we have this cloud API for App Layer is based in REST API. Can it be connected using PowerShell?
I can take that one. So the answer is yes. It is a REST API, and you can use PowerShell. And I've actually written a bunch of PowerShell scripts. And when the product actually comes out for release, I'm going to publish them in a blog and publish the scripts, so they'll be available to you. If you would like them beforehand because you want to get into the tech preview, which is available, if you shoot me an email, I can send you the scripts that I already worked, and that'll save you a lot of time to figure out how to do them.
I think we're having momentary technical difficulty, but we'll be right back. So I actually I said compositing engines a few times. I don't know. I'd like to talk a little bit more about it, and there were some earlier questions that I saw on the chat window. So until Michelle dials back in, maybe I'm just gonna fill the moment with a little bit extra information on that, if that's okay. So I mentioned that there's sweeping technological changes or architectural changes in the product, and one of them is the compositing engine. We really have prioritized the implementation of compositing engines for a few reasons, and as an engineering manager, I really love the direction, and because it's a direction that gives short-term benefits and long-term benefits at the same time. So it's a great next step. So what it does is traditionally app layering product has depended on a central appliance that was Linux-based, which obviously we call Elm, Enterprise Layer Manager. And Elm is the traditionally the master of the compositing operations and store of the layers resulting from those operations. So it's the central kind of hub, the brain of the operation, so to speak. However, in the more cloud native, cloud friendly architectures of the future, Elm almost becomes a scale issue and a single point of a bottleneck for operations. So one thing that we are aiming and we've achieved with compositing engines is for customers who need highly parallelized operations with multiple publishers, like some customers we hear of have dozens of publishers being kicked off from updates. So the operations used to be bottlenecked by the Elm's resources because Elm is a single VM, and we deliberately optimized it at four packaging and publishing operations simultaneously. So that barrier is broken with compositing engines. Now you can have as many of those operations as your resources allow you to on your hypervisor. So that's one huge benefit. And then the other benefits are compositing engines are running on the destination hypervisor, so they can use some of the native file formats that hypervisor supports and can use. So we were able to take advantage of thin provisioning, thin disks on especially vSphere. And on top of it,
that's an important one, Ozan, because of the speed performance benefits there, right? We don't have that stuck at 100% while we're expanding the disk for quite a long time.
Absolutely huge, because the unnecessary transfer of data doesn't happen. And then one other subtle advantage is because the compositing is happening on the destination, we avoid one copy. Thin or thick, the disk is not moving one more time from being composited on the Elm and being moved to the hypervisor. That step is direct. It happens on the hypervisor itself. So for numerous reasons, and also the additional support of VHDX on Hyper-V, et cetera, UEFI support for, again, in OS layer revisions so far, but it's possible to use that for publishing images already. So for numerous benefits, it is an excellent step for the product, and we're really proud of it. And in long term, it allows us to be more service-oriented and more cloud-friendly for integrating with different workflows and even multi-tenancy ready. So yeah, it's a great step, and I just wanted to highlight that it's a strategy that gives advantages in the short term and long term at the same time. That's one of the reasons why we prioritized it and targeted to our largest percentage customers possible with Hyper-V and vSphere so far. And again, we're going to expand in the future. Our goal is to make it available on all platforms we support. I just wanted to kind of wrap up why are we doing it and what is it.
Awesome. Thank you so much. And I know we are running a little bit over time. We still have a lot of questions to address, which is awesome. We're glad you guys are so curious and engaged. I'll do a couple more questions. And then, of course, be sure to keep an eye out. We will do a follow-up blog, a FAQ, where we break down all the questions that came in. So if we don't have time to address your question today, definitely keep an eye out for that blog. And let's see oh gosh, there's just so many questions. So
one thing that I've seen a few of, Michelle, is it supported on 715 LTSR, and I think that's UPL. And the answer is no. You need to use the 1912 LTSR or later for UPL.
Okay, perfect. And then last one, I've seen some questions about Silverlight. So when will the Silverlight console be updated to HTML5?
I can take that. That's also a frequent request that we receive. It is a bit of a historical tech debt for the product. Essentially, it's an old and obsoleted technology on a number of platforms. So the answer is, as the product and the technology gets used in different ways, a one-to-one replacement is making less and less sense for us. So the UI of the future might come from different areas. Some of it might be hanging off of Studio workflows. Some of it can be on Citrix Cloud. So a one-to-one, we kind of missed the window of a pure one-to-one replacement. I think that take Silverlight out, drop HTML5 or preferred technology in is less and less a possibility. So, but that doesn't mean that Silverlight will be the only way to work with the product. We're taking API-first approaches so that the functionality is available programmatically, and the UI of the future will be in unexpected places, but it's not going to be directly on an appliance administrative UI, possibly. So that's my short answer. If anybody's interested, I can give more details. I know we're limited on time.
All right, no problem. Thanks again, everyone, so much for joining. We appreciate your time, and again, sorry for going over. But like I said, keep an eye out for that blog, and also be sure to save the date on June 10th for our next Technology in Practice webinar. We are going to be partnering with Microsoft for that one, so it's a don't miss event. But other than that, I appreciate everyone. I hope you guys enjoyed this and learned a lot. And again, we look forward to giving you more tips in the future. Thank you so much. And thanks again to Rob, Dan, and Ozan for helping to field the questions and do the presentation. Have a good one.
Thank you, Michelle.
Hi, everyone.